Now in this video, I want to introduce you to the idea of static members in your classes. And the best way to understand these is just to see one happen. So let's just jump right into it. The first thing I need to do is build a class, and I'm going to include static members in that class. And so we're going to create a class, our cat class that we've been using all throughout the course here. And I'm going to go ahead and set the braces up so I don't forget them. And so let's start off with, first of all, everything I'm going to create in this class is going to be public. So I will put that in there. And what I'm going to do is just first of all create a function, and then we'll play with it a little bit and then come back and change it. So I'm going to create a function that returns an integer called add these, and then I will pass in two integers when this function is called. And all we're going to do, very complex here, we're going to try to spell return. That's complex enough for me. A plus B. So whatever you pass in to add these, it's going to add them together and then throw them back at you. Okay, pretty straightforward. Now the way we've always done this in the past is, we would take a data type of cat, which is our class type up here, and then we would instantiate an object called C1, and then from C1 we would call add these, and then we would pass it say 5 and 6, and that would give us a result. Well, to see our result here, what we are going to do is put this in a output to the console. Alright, and so I'm just going to move this up here, and that should do it, So I have created a class called cat. I've put a function in there called add these. It returns an integer, and whatever I pass into it, the two numbers, just going to add them up, throw it back at me. And so when I run this right here, that's what I should see on my output. Alright, and I will build this, and you will notice that my project name is static example. I didn't show you that. Project name static example. You will see this out in your work files folder. And so now to run this, I just need to go to the location where it is, clear this out, and if I just type static example, and let me back up here before I do that. That was out there from a previous run through, but if we go out to our documents, I'm in Windows 7, and we go to Visual Studio 2010, and we go into projects. There you will find static example, And if I go in there, debug is where my executable file was actually built when I compiled. So I'll right click that, open window here, and call static example. Okay, notice the answer that it returned right here, it's kind of hard to see, is 11. And guess what that is? That is what happens when we add 5 and 6 together. Now that's no big deal, I've wasted 3 minutes to show you the same thing we've done plenty of times before in the class. Well, let's take a look at a little different thing here. What if I put the word static in front of this, and it will start to change things? Now notice it didn't change anything down here, but what static means is I can access this directly through the class without first instantiating an object of that class. Let me show you what that means in English. I will take this away, and notice it says, oh, wait a minute, dude, what are you talking about? C1's undefined. You talking about a class? What are you talking about? Well, to access this now, I just type the name of the class, 2 colons, and notice it sees add these out here now. And so notice I can access add these and pass it some numbers. I'm going to give you some different numbers here so that we can tell that it's working. And so basically I'm getting to the add these function in the cat class without instantiating an object beforehand. Okay, so no object instantiations having to occur here by me to make this happen. So let's compile this, and then we will jump out, run static example, and you'll notice that it worked. Notice our result set right here is 20. Alright, and 8 plus 12, get out your calculator, that does equal 20. Okay, so what you're looking at there is a static member, a static function, and I can always get to it. Now you will see this all over the place in real world code because people put these out there and they want to be able to get to them, and they just want to be able to hit them and throw little things like this at them, do whatever they want to. But that is what a static function looks like. Okay, now in part 2 of this, I want to show you a static data member, and it does something kind of unique. So join me in part 2 and we'll go a little deeper with static members. Welcome to Static Members Part 2, and in Part 2 I'm going to continue what we started building in Part 1, but this time, as opposed to working with static functions like we did in Part 1, I want to introduce the idea of static data members to you. Now this is really interesting. I'm going to create an integer up here that's called number objects. All right. Now what's really interesting is I'm going to come back to the front of it, and you guessed it, I'm going to put the word static there. Now what I just created is an integer called NBR, or number objects, that is going to be available and updatable by every object that is instantiated from this class, or whenever I'm calling this thing statically from the class. All right. So best way to see this is to come down here, and we'll first use it as by instantiating objects, because I want you to see the results of what you just did. Okay, so I'm going to take C1. Let me make this a little easier for you to understand. I'm going to call C1 number objects, right, and I'm going to set it to 2, and then I'm going to come down here and take C2 number of objects, and I'm going to set it equal to 15. All right. Now before I actually use this in my integer main, I will need to initialize it, and so I'm just going to do number objects, and I will set that equal to 0 to begin with. Okay, I could have done it inside here, but I'll do it out here. All right. Now what's going to happen here is I've set number objects to 2 with this object, this instantiation of cat C1. Then I created another object C2. Now these are 2 separate objects in memory, but they're both using the same variable here, if you will. Okay, because notice I set C1 to 2, C2 to 15, and now if I just output, and I'll copy this, if I output this and output C1 dot number objects, you will notice that C1 is now equal to 15. Okay, because 15 overwrote 2. So let me compile this and let's go take a look at it. Now keep in mind we're going to return a 20 here because we're getting 8 and 12 the first time. Okay, so what I'm going to do is clear this off, run static example, and sure enough there's our 20 from this adding 8 and 12, but then there's 15. And notice I printed out C1 number of objects, and right here I had set C1 equal to 2, but then when I put it to 15 it overwrote it, because that static object or that static integer up there is available to anybody. But we could do some really neat things with this. First thing let's do is, what if we were to count the number of objects that we ever have out there in memory? All right, so if I create a constructor, and if you remember how to do a constructor, you see what I'm doing. If you don't, go out and take a look at the videos on constructors. But all I'm going to do is put in here number objects, and then I'm just going to increment each time. All right, now notice that before I started to run my program, I initialized it to 0. All right, and every time I create a new instance of class, number objects is going to get incremented by 1. All right, and so what I'm going to do here is do cat C1, cat C2, cat C3, probably see a pattern developing, cat C4. Okay, and now I am just going to come down here and I am going to use that. I need colons instead of semicolons there, okay, for a number of objects. All right, and let me add something there to make this a little easier. There are that many cat objects. not open, let's say in memory. And I'll close that. All right, now if I got all that straight and easy to read, we're going to see we have instantiated 4 objects. All right, and so let's run this, compile it, and then we'll jump out, actually execute it, and see what we get. Okay, and there we go. Notice there's our 20 from our 8 and 12 up here. I add these, but notice there are 4 in memory, right? Because that's what we created. All right, so let's take 2 of these off, and then let's recompile, and we'll go out and run the static example again, and you'll notice there are now 2 in memory. So it's actually counting the objects that we have in memory. This example was done specifically to let you know, can I do static variables in my classes? Yes, you can, but you got to understand that these things persist and are shared across all the objects that are created by this cat class. Now, while that's a warning, that's also a great tool that you can pull out of your developer toolkit from time to time and persist certain pieces of data, counts, that sort of thing, totals across multiple classes. You have to be very, very careful with this. Very easy to lose control of it and to kind of hurt yourself, okay, with logic errors. But I wanted you to see a little bit about these static members. Some pretty cool stuff here.